Hi everyone, dear students, I welcome you to my channel HKB Maths classes, and this will be lecture 2 on miscellaneous exercise of integral. And today we are going to discuss some very important questions, okay, of miscellaneous exercise. And today we'll just discuss indefinite integrals. Okay, in the lesson 1 we did some questions, and today we'll just start from question number 19. Okay, this question number 19 is also very important, and it's got certain steps. Okay, we'll just can start a sum like that. Let us assume that let I is equal to sine inverse root x minus cos inverse root x by sine inverse root x plus cos inverse root x dx. Okay, and since x belongs to 0 to 1, so just use the property of inverse trigonometric function. This is sine inverse root x plus cos inverse root x is equal to pi by 2. So similarly, you just use the same property in the numerator also. This is sine inverse root x minus is cos inverse root x, that is sine inverse root x plus cos inverse root x is equal to pi by 2. Therefore, this sine inverse root x, and in place of cos inverse root x, you can just write pi by 2 minus sine inverse root x dx. So just if we simplify the numerator now, this is pi by 2, and if we just add this sine inverse root x minus plus, this is sine inverse root x, so just get 2 sine inverse root x minus pi by 2. Okay, dx. Fine. And now, okay, now just we can simplify the remaining steps this way. Okay, what's the next steps? Okay, so just we can pi by 2 just write as a coefficient. Okay, this will be 2 by pi, and the first term is, we just write this 2 sine inverse root x, okay, and minus pi by 2 dx. And in case we just multiply its term, okay, we just separate into two integrals. If we multiply the first term, so it's 4 by pi sine inverse root x dx minus, we just multiply by 2 by pi and pi by 2, which gives 1. It's okay, integration of dx. Now this particular steps, okay, we just can write 4 by pi, and this integration of sine inverse root x, we can just mark this is I1, and integration of dx, okay, just can write x, or we'll just keep like that. So we'll just mark this is equation 1. And here in this question's most important step is this: how to integrate integration of sine inverse root x dx. We'll integrate this one, and we'll just substitute this in this equations. This is I. Okay, we'll just move to the next page for this. Since already we are assuming here I1 equal to sine inverse root x dx. Fine. I1 is equal to, okay, just will assume that let root x equal to t. Fine. Root x equal to t. In case root x equal to t, okay, so x is equal to t square. So you can differentiate dx equal to 2t dt. Fine. So this gives us sine inverse root x equal to t, and dx is equal to 2t dt. Fine. Next, 2 we can just write as a coefficient, that is then t sine inverse t dt. Now this is an important function, that is algebra plus inverse trigonometric functions. So that we can integrate with the help of integration by parts. So here 2. So the first function will be obviously the inverse trigonometric functions, and we'll integrate t. If we integrate t, it will be t squared by 2 minus. So that's sine inverse t is the first function. We'll just differentiate this. If we differentiate, this is 1 by 1 minus t squared. Now we need to integrate the second function. The second function is t integration is t squared by 2 dt. Okay, that whole thing is multiplied by 2. Next, just can separate this integral. We can just multiply by 2. The 2 will cancel out. So it will be t squared sine inverse t and minus these 2 and these 2 will get cancelled out. We'll just get t squared 1 minus t squared fine dt. So this sum we just multiplied by 2. So this gives us t squared sine inverse t. And this second integral will just multiply by 2 to get cancelled out. So it gives minus integration of t squared under root 1 minus t squared dt. Okay. Now how to integrate this? Another important step is here. How to integrate integration of t squared under root 1 minus t squared. We'll just follow a very simple method to integrate this. T squared sine inverse t. Instead of minus, we'll just write plus, and this minus will be writing as minus t squared. Fine, minus t squared, and just manipulate the numerator as 1 minus t squared minus 1. Okay, the reason is this term is 1 minus t squared. We're just trying to write the numerator in the form of 1 minus t squared. So in case if we just write this one, if we convert t squared in the form of 1 minus t squared, we need a minus there. So obviously you can just erase the minus sign with the help of this minus. You can just make this minus plus, and this minus you can just bring to t squared. So just can write minus t squared. If you write 1 plus, you can just have to subtract 1. Yes. So this is dt. Now we can integrate in this way. Look, t squared sine inverse t, fine. We'll separate this one into 2 integrals. We'll just divide 1 minus t squared by under root 1 minus t squared. This 1 minus t squared will divide by this, so we'll just get 1 minus t squared dt. So what is the second integral? Second integral is dt by minus dt by 1 minus t squared. Fine? Okay, next. This is t squared sine inverse t, and plus this, we know this is a standard integral, that is under root a square minus x squared. So this gives us x into a square minus x squared. A square means 1 square, 1 minus t squared by 2. Okay, plus a square by 2, a means 1, so half, right? A square by 2 sine inverse x by a. X means t by a is t. Just get this. So this is a very simple the steps, and with the help of this standard integral. Alright. Now this is also another standard integral, that is the integration of dt by under root 1 minus t squared is sine inverse t. So for this solving all this question, you have to remember all the formula. Okay, and we can just simplify a little more than this. This is t squared sine inverse t, fine, and plus, okay, this is t 1 minus t squared by 2, and these two terms, that is half sine inverse t minus sine inverse t, right? Okay, here just have to write a constant after integration 6. Okay, then half sine inverse t minus sine inverse t gives us what? This is minus half sine inverse t plus c. Now just substitute a value of t. Okay, so what did we substitute in place of x? And we do remember that in place of root x we will substitute t. Fine. So hence, what's the value of x? X gives us t square. So we need to substitute this value. So in case if I just write this value here, t square is x, and sine inverse t is root x, right? Okay, plus 2. What is the value of t? T value is root x, and this under root t square is x, right? And minus half. Okay, this is minus half sine inverse t, that is sine inverse t value is root x. We can just plot this and plus c. Okay, and next we can just simplify a little more than this. Okay, like x sine inverse root x plus, so how to simplify? We've seen like there is a term sine inverse x, sine inverse root x, and in the third term as well. So just take a sine inverse root x from the first and the third term. If we just take sine inverse root x out, so this gives us x minus half. Here x is there, here half is there, sine inverse root x, fine. And this we can just write as half. And you can just multiply these two terms. If we multiply this root x into root 1 minus x, so it will be x minus x squared. Because you can multiply this one by taking a common set, you can just multiply 1 minus x and x. So x minus x squared. Okay. Already this term and this term have combined, and this term you can just write this one and plus c. And now you need to remember what is I. Well, let's go back to the previous page. What is I? I is equal to, remember this, I is equal to 4 by pi I1 minus dx. Okay, 4 by pi I1. We'll just move to this. Okay, we know, okay, I is equal to 4 by pi I1 minus, okay, integration of dx. Now we'll substitute a value. Okay, 4 by pi, we can just multiply this one by 4 by pi into x. So we just can take LCM. This is 2 and twice x minus 1. Fine. So we'll just multiply each term by 4 by pi. Okay, that is 4 by pi, and if we just multiply this will be twice x minus 1 by 2 and sine inverse root x. Next, we need to multiply this term by this term, second term, by 4 by pi. So if you multiply, okay, plus 4 by pi into half, so it will be 2 by pi x minus x squared. Fine. So I'll just multiply this one by 4 by pi into twice x minus, okay, 1. And this also you have to multiply by 4 by pi into half. 4 by pi into half gives us 2 by pi under root x minus x squared. And don't forget dx minus dx is x. Okay, minus dx is x, and this constant, and we just write one constant there. Okay, alright, this constant, and if you get dx, will get another constant, and together we can just write plus c. We can just write one more steps. Okay, finally, so it's almost done. So you can just leave it like there, or if you want to simplify, you can simplify one step. This will be 2. So finally, what's the answer? 2 by pi, right? And twice x minus 1 sine inverse root x plus 2 by pi, okay, and x minus x squared minus x plus c. So this is this particular questions, and that's the reason it has got different steps, and steps are more as we just try to simplify as far as possible. Okay, and you need to practice a lot for this type of questions. Okay, just we can move to another question. That is, okay, this is question 20, and like question 19, this is also a very important question. Okay, and this is standard form to solve this type of questions, and that's why I thought like let us discuss this type of questions. Okay, integration of under root 1 minus root x 1 plus root x. So what's the simple substitution is this? We'll just substitute root x equal to cos 2 theta. In fact, we can just substitute root x equal to cos theta as well, right? The moment we just substitute 1 minus cos theta, 1 plus cos theta, we just have a formula for each of the expression. That is, we have a formula for 1 minus cos 2 theta, we have a formula for 1 plus cos 2 theta, and that is a logic like we select root x equal to cos 2 theta. It's just if you differentiate 1 by 2 root x dx equal to differentiation of cos 2 theta gives us minus 2 sine 2 theta d theta. So this is the differentiation of cos 2 theta, and let's simplify it a little more than that. Dx, if you cross multiply, it's minus 4 into root x. What is root x? Cos 2 theta. Cos 2 theta and sine 2 theta d theta. Fine. So let us check that. Root x differentiation is 1 by 2 root x dx, and cos 2 theta differentiation minus 2 sine 2 theta d theta, and we need the value of dx. So if you cross multiply, so it's minus 4 and root x. Root x you can substitute as cos 2 theta sine 2 theta d theta. Let's see what we can just how we can simplify the next step. So just write I equal to, okay, and this is 1 minus cos 2 theta by 1 plus cos 2 theta. Done. And we'll write the value of dx now. What is the value of dx? Dx value is this. Okay, dx value is minus 4 cos 2 theta sine 2 theta d theta. This is the value of dx. Okay. Next, let's start simplifications now. So quickly you can just simplify 1 minus cos 2 theta, 2 sine square theta. And this one, 1 plus cos 2 theta, 2 cos square theta. You can cancel 2, 2. Okay. And this minus 4. Okay. This minus 4 we can just write as a coefficient. This is minus 4. Okay. And this is cos 2 theta. And this sine 2 theta, you just can write in the form of 2 sine theta cos theta. So just get the logic, like why you need to subtract, why you need to split this function. Okay, just get the idea the moment I write the next step. Okay, it's minus 4. And if we take the square root, this is sine theta by cos theta. And this is cos 2 theta into 2 sine theta cos theta d theta. Fine? Right? So only because of that, so that we can cancel cos theta, we need to split sine 2 theta. So it's an every steps, you know, like in math there will be a logic. So you don't need to mug up anything. Right, okay, because in case like if you think in this way, so how do you remember, like, okay, that generally the student keep asking about it, how do you remember the substitutions, what you need to substitute, and how do you remember, like here we don't need to, because cos 2 theta also has got many expressions, many formula. So why you need to like split the sine 2 theta, not cos 2 theta? The logic is that sine 2 theta can be expressible in the form of 2 sine theta cos theta, and 1 cos theta you can just cancel it. Right? The moment you can cancel this, it gets simplified. That is the only logic. Okay. Let's go ahead. And in integrations, you know, integrations means like you need lots of practice. Okay. Next, we can just simplify the guy. It's minus 4. Remember this? It's minus 4, and you can of course multiply with 2. Right? If we just multiply it with 2, okay, we'll not use this 2. There's a reason for this. Okay, this sine theta and 2 sine theta, we just use together. So I'll just tell you the reason. I'll just write minus 4 cos 2 theta, and I'll just write 2 sine square theta. Right? Cos 2 theta I have written, 2 sine square theta d theta. Now I'll tell you the reason, like why I thought I just multiply with 4, but the moment I have seen 2 sine theta and sine theta, okay, it's coming to my mind, right, yes, we are getting a chance to use a formula, because this function is in form of cos and sine. In case this one also you can just convert to cos, it becomes more easier. So we have a formula cos 2 theta in terms of sine. What is the formula in terms of sine? 1 minus 2 sine square theta, right? So this is equal to, right, 2 sine square theta 1 minus cos 2 theta, right? 2 sine square theta 1 minus cos 2 theta. So that's a logic, like we are writing 2 sine square theta form. Okay. So this is minus 4 cos 2 theta, and 2 sine square theta is 1 minus cos 2 theta, right? 1 minus cos 2 theta. Now, but just slowly, just coming to towards the end of this particular the question, we just can multiply cos 2 theta, and we'll just multiply cos square 2 theta d theta. Okay, we're just integrating now. Minus 4 cos 2 theta d theta, then minus minus plus 4, right? Cos square 2 theta d theta. Now this is you can directly integrate, and cos square 2 theta also need to convert to linear form to integrate it, but still very simple steps. Okay, and we just has got 2-3 steps left for this particular questions. Otherwise, all important steps it's done for this question. So it's minus 4. We'll just integrate this cos 2 theta, integration is sine 2 theta by 2. Okay, this is plus 4. Fine. This is plus 4 and cos square 2 theta, right? Cos square 2 theta, which is can write in the form of, okay, half 1 plus cos 4 theta. Right? So we are using the formula of cos 2 theta, right? Cos square 2 theta is half 1 plus cos 4 theta d theta. So if we just cancel it, it's minus 2 sine 2 theta, minus 2 sine 2 theta, and 4 we can cancel it 2 right? And just we can integrate 1 into d theta. This is d theta and plus, okay, plus 2 integration of cos 4 theta d theta. Please check this, that you can just cancel it. It will be minus 2 sine 2 theta, and half and 4 you can cancel out, so you'll get only 2 there. So first term will be 2 d theta, plus you can multiply the second term as well by 2 integration of cos 4 theta d theta. And finally you can just write all the integrations now. 2 sine 2 theta plus 2 theta, and this is 2, and cos 4 theta is sine 4 theta by 4 plus c. It's done. Now we need to remember, like, what we did substitute, right? What did we substitute for x? Okay, we did substitute root x. Remember this, cos 2 theta. We did substitute root x equal to cos 2 theta. So therefore minus 2 sine 2 theta, you can just write it 1 minus cos square 2 theta. So you can just write 1 minus cos square 2 theta. Cos square 2 theta will give us x. So it's minus under root 1 minus x plus 2 theta. What is the value of theta? Theta 2 theta is equal to cos inverse root x. So theta is half cos inverse x. Okay, half cos inverse x. 2 is there. Or you can just directly write the value of 2 theta. 2 theta is cos inverse root x. Okay, instead of this, you can just directly write. So it's 2 theta. So why don't you write 2 theta is cos inverse root x? Fine. Plus. And this is half. And sine inverse 4 theta. So how to write sine inverse 4 theta? Sine inverse 4 theta you can just write as 2 sine 2 theta cos 2 theta plus c. So 2 sine A cos B formula. Fine. So it's 2, okay, 1 minus x plus cos inverse root x. Fine, cos inverse root x. And you can just cancel this. 2 you can cancel, and plus, and sine inverse 2 theta. What is sine inverse 2 theta? Cos, okay, cos 2 theta first we'll write. Cos 2 theta is root x, and sine 2 theta. Sine 2 theta under root 1 minus x. So it's under root 1 minus x plus c. It's done. So this cos inverse root x you have written, right? 2 theta is equal to cos inverse root x you have written, and 2 and 4 you can just cancel. It's half. Sine 4 theta we are using the formula 2 sine theta cos theta. Sine 2 theta formula. So therefore sine 4 theta is 2 sine 2 theta cos 2 theta. Cos 2 theta is already there root x, and sine 2 theta is square root of 1 minus sine square twice theta. Sine square twice theta is x plus c. Okay. So we can just write one more steps here. Both the steps is equal to minus 2 1 minus x. Fine. You can just club this together. So if you just club this together, you can just write, you can just multiply this function together. So it will be x minus x square. You can just write this way. Fine. And plus cos inverse root x plus c. So it's minus 2 under root 1 minus x plus under root x minus x square plus cos inverse root x. Okay. This is 1, 2, 3 and plus c. It's done. So this is also a very important questions, okay, in that particular exercise. Let's just move to another question, that is question number 21. And this question number 21, this question 21 is relatively easy, okay. And I hope you just remember this. That is, this is standard formula, okay. Ex, standard form, like Ex fx plus f plus x. Do you remember this? This form Ex fx plus f this x dx. Okay, just let's try to convert this one to that form. That means we'll just try to write this one as a sum of two functions fx plus f this x. So we just can simplify like that. So 2 plus sine twice x is 2 sine x cos x, right? 2 sine x cos x. Then 1 plus this cos twice x. Right? This cos twice x you can write in the form of 2 cos square x minus 1. Okay? This 1 plus cos twice x you can write 2 cos square x minus 1. Okay? And this is Ex dx. Fine? Ex dx. If you simplify this, and you can cancel 2 from the numerator and the denominator. So it's 1 plus sin x cos x, and denominator has cos x square x, ex into dx. Okay. Now since we know that this particular expression we need to write as a binomial, sum of two terms, so this individual, let's divide this. So if you divide 1 by cos x square x, it's sec square x, and if we divide these two terms, 1 cos x will get cancelled out. Sin x by cos x is 10x. Fine. Ex dx. Okay. And what's the next step now? This is equal to. Okay. Now let's see that. Right. We don't need to write more steps. So if you consider this is fx, what is the differentiation of 10x? Differentiation of 10x is sec square x. So it's exactly in that form. So in case if we get the integral in the form, we know that ex, the answer is ex fx plus c. So therefore here fx is 10x. So answer is 10x into ex plus c. So this question has got less steps, and only thing is that this question is given from this particular form, and you should have a practice for this, and you should remember this. Okay. Next, we'll just discuss about these questions, right? And this also important questions. And if you have seen, like before, sometime we had did a question 1 minus root x 1 plus root x 1 plus root x form. So then we did substitute root x equal to cos 2 theta. So the substitution for this question will also be in that form only. So here what we will substitute? X will just substitute cos 2 theta. So if we substitute x equal to cos 2 theta, we'll just differentiate. If we differentiate, this is minus 2 sin 2 theta d theta. Remember this. Okay? And already I explained what's the logic behind substitution of x equal to cos 2 theta. So this we can just consider as I. So tan inverse, okay, 1 minus cos, 1 minus secant, 1 minus cos 2 theta, okay, 1 plus cos 2 theta, right? I don't think that again I have to explain all this steps, because just now I have explained about this type of questions. Dx is minus 2 sin 2 theta d theta. This is the value of dx, right? Now this minus 2 which is can write as a coefficient, this minus 2, okay, so just write this minus 2 as a coefficient, right? So it's tan inverse, and this is gives 2 sin square theta, and this is 2 cos square theta, 2 cancel out. Anyway, just let me write the steps. 2 sin square theta and 2 cos square theta, done. This is sin 2 theta d theta. Now minus 2. So this will cancel out, and sin square theta by cos square theta is tan theta. So tan inverse tan theta is theta, right? Theta and sin 2 theta d theta. Fine. So it's coming to a very simple form, that is minus 2 theta sin 2 theta d theta, right? And we know that we can easily integrate these functions, that theta sin 2 theta d theta. We can just move to another page, okay? That is, we'll just continue with this minus 2 theta sin 2 theta d theta. This is I. We'll just continue with this minus 2. This steps that where we have left, right? It's minus 2 theta sin 2 theta d theta, right? Okay. Minus 2, we'll just go for integration by parts, theta sin 2 theta, right? We'll just take theta as the first function, we'll just integrate sin 2 theta. If we integrate sin 2 theta, it will be minus cos 2 theta by 2. Fine, this is the step 1. And minus, okay, minus integration of. We'll just differentiate the first function, theta. If we differentiate theta, it will be 1. With respect to theta, it will be 1. And we'll integrate sin 2 theta. Sin 2 theta integration is minus cos 2 theta by 2. Minus cos 2 theta by 2. Okay, d theta. Then we need to simplify now. So we'll just multiply each term by minus 2. So if we just multiply the first term, minus plus, 2 will get cancel out. So it will be theta cos 2 theta. Done. Theta cos 2 theta. And there 1, 2, 3. So it's minus, right? It's minus sign. And this 2 will get cancelled out. Okay. We'll just get only what? Cos 2 theta. D theta. Cos 2 theta d theta. And finally, this theta cos 2 theta. And if you just integrate cos 2 theta, so it will be a sine 2 theta by, right, and a plus. So steps are it's becoming very simple, okay, only because of the correct substitutions. That is, this minus minus, it's plus to cancel out, it's theta cos 2 theta, and this minus, and this, there are two other minus signs, plus multiplied by minus. So, and this 2 and this 2 will get cancelled out. You will get only cos 2 theta, and cos 2 theta, right? Cos 2 theta integration is sine 2 theta by 2. What's only one thing is left out here? You need to substitute a value. What do you substitute in this case? For this question, we need substitute x equal to cos 2 theta, right? We need substitute x equal to cos 2 theta. So, right, theta. What is the value of theta now? Cos 2 theta, we know that cos 2 theta is x. This cos 2 theta is x. Now we'll just substitute theta value. Theta is 2 theta is equal to cos inverse x. So theta is half cos inverse x. Okay, this is half cos inverse x. You can just write like this way. It's minus half and sine 2 theta. Sine 2 theta, you can just write sine 2 theta. You can just write in the form of 1 minus cos squared 2 theta. So cos squared 2 theta is x squared. So it's half 1 minus x squared. In place of sine 2 theta, you can just write and plus c. Okay, and this is the answer for these questions. And today we'll sign off with this particular question, and in the next video, okay, we'll discuss about the both indefinite and definite integral. And thank you for watching, and keep watching. And I request you that you do subscribe so that you keep getting information regarding the channel, okay, regarding the latest uploads or updates. Okay, thank you so much.